Hello everyone. In this video I'm going to go over the stack. I'm going to look at some methods that we use, and then I'm going to show you the code and how it works. What is a stack? A stack is a linear structure. It has a push and pop methods, and there is first in and last out. You'll see what I mean by that in a minute. The push method uses append, and the pop method uses pop, and I'll explain why it's done that way when we get round to the code. Both of these run in constant time, so it doesn't matter how much the list changes, these operations are still going to be the same cost. Other methods we use is empty, peak, and size. So these give us information about the stack itself. Let's have a look at what a linear structure is. So we have linear structure like this. And you have some values in there. So it's going to have like points of interest here, which are going to be this point and this point. It's basically, it's like, we would call that the bottom. This could be the top, or it could be the beginning and end. But we tend to think of it as top and bottom, because a stack implies that you've got something down here and then something is stacked up on top of it. So then you have something else stacked up and something else stacked up, and so you would have 1, 2, 3, and 4 if you had a list that was 1, 2, 3, and 4. So this guy here that's the last in. So last in, and then so it's going to be the first out. So that's where we get last in, first out from. To push something in, that's where we use push. And we're going to create a method for that. And then you would push something in, so like 5, so then that would now be at the top of the stack. You would have pop. So you're going to pop a value out. So if we pushed 5 in and then called pop, our stack would look like this. So we would have 1, 2, 3, 4. We push 5 in, and then we pop it out, and then it returns to just being 1, 2, 3, 4. The other methods that we use are is empty. So this is going to check to see if there's actually anything in it, and it's going to return either true or false. We have peak. This is going to allow us to have a look to see what's at the top of the stack without actually performing any functions on it. And we have size, which is going to return the size of this list here. Now, I know that we can use pop dot pop, but we're going to put it in a method so that you can only use pop in one way, and that is to pop this last guy here. We want to make sure that push is, we're going to use dot append, so we guarantee that it's going to append it to the last item in the list. We have a class stack, and in this first method here we're going to create a list. It's just an empty list. Then in push, which takes one argument because it needs something to be pushed to the stack, where we're going to just append the item to the end of the list. Pop, this takes no arguments apart from self, so you don't need to put anything in. It's going to pop whatever is on the end of the list, but pop itself takes an argument. So you could pop something out that wasn't at the end of the list, but we don't want to do that. So we put it in this method to make sure that only the last thing in is popped out. This commented out code is just code that I can use to show you how the code is running. Is empty. This line of code here is just going to check if it's empty. Peak, this is just going to return the length of the list, the last item in the list. It's going to check out the length of the list and return the last item in the list. That's what the -1 is about. And size just returns the length of the list. So let's have a look at the code. Make sure that this is running. Okay, so if I do and now do is empty, it says true, it returns true. So this is just going to return true or false if the list is empty or not. So if I push something to it now, so if I do and we push 1 to it. Now if I do is empty, it returns false because it only returns true if the list is equal to an empty list. So if I push something else to it, 2, and then we have a look at peak. It returns 2 because that was the last thing that was pushed in there. And if we do size, that returns 2 because there's 2 items in it, which were 1 and 2. So if I keep on pushing things in there, 3 and 4, we can't really see what's in the list. So if I do the pop, and now we do peak, it says 3. So if I do pop again, and then we do peak, it says 2. So now if I uncomment this and then run it, if we clear this, create another stack, and then populate it. Now this here is the list. We can see the list grow. So if I do that again and put 2, now 2's been added to it. So you can see what's going on now. And put 3. 3's added to the list. You can see that this is growing. So you can see that this 1 here, that's the bottom of the list, and this 3 is the top of the list. Now if we do peak, it's going to return 3 because 3 is at the top of the list. Stop check. We can now see the list. Index 0 holds 1, index 1 holds 2, index 2 holds 3, which is what we have up here, 1, 2, 3. So peak has not taken 3 out. It's just allowed us to peek at what's going on in there. So now if we do pop, what this is showing us is that there's the list and it's popped 3. So the list is now just 1, 2. And we can do that by going back to check. And it shows us that there's just 2 entries in here. 1 and 2 at 0 and 1. We do pop again. And that pops that out. And we do pop again, and now the list is empty because the last item that we popped out there was 1. What happens if we do pop again? It doesn't like it. It's out of range. So this pop just pops out the last thing that was on the list, which is going to be like here it was free. And when you push into the next index. So we had 3 at index 2. So if we push 4, that will be pushed to index 3.
If you liked this video, give it a thumbs up and try out one of my other videos.